This day and time. What happened today, years ago?
What happens when you poke the atmosphere with a stick made of pure, explosive energy? We found out in the summer of 1962, and the answer was far more complex and surprising than anyone could have predicted. Imagine our planet not just as a solid mass, but as a delicate system, wrapped in invisible layers like the skin of an onion reaching far out into the void. For a long time, as humanity began to venture beyond the confines of the ground, there was a prevailing thought: what we did way up high wouldn't really matter much down here. The upper atmosphere, near space, it seemed vast, empty, a place where you could perhaps experiment with impunity, like throwing a pebble into an impossibly large pond. But on July 9, 1962, the United States decided to throw not a pebble, but a thermonuclear boulder. This was an experiment, one with a rather innocuous-sounding name: Starfish Prime. The goal was to detonate a nuclear device high above the Earth to see what would happen. They launched a Thor missile carrying a 1.4 megaton warhead from Johnson Atoll, a tiny speck of land in the middle of the Pacific Ocean. The target wasn't a landmass or a military installation, it was the sky itself. The rocket climbed, piercing the dense lower atmosphere, soaring higher and higher, up, to an altitude of 400 kilometers. That's roughly the height of 400 Eiffel Towers stacked on top of one another, well above where airliners fly, nestled within the ionosphere and lower magnetosphere. And then, at that incredible height, it happened. Boom! A blinding flash, a man-made star briefly flickered into existence where only the deep, silent black of space should have been. It was a spectacular, terrifying sight, visible for thousands of miles across the Pacific. But the visual spectacle was just the beginning of the story. This wasn't just a loud bang in the sky. It was an injection of raw explosive energy into a system we barely understood. And the effects were immediate, far-reaching, and utterly bizarre. One of the first undeniable signs that something significant had happened occurred about 1,450 kilometers or 900 miles away from the blast site. On the Hawaiian Islands, streetlights suddenly went dark, plunging neighborhoods into unexpected shadow. Burglar alarms started wailing without cause, and telephone lines went fuzzy, disrupting communication. What force, unleashed high above the Pacific, could reach out across such a vast distance and interfere with mundane electrical systems on the ground? The answer was an electromagnetic pulse, or EMP. The explosion generated a massive, invisible wave of electrical energy that radiated outwards at the speed of light. Think of it like an invisible tsunami of electricity. But this wasn't just any EMP. The high-altitude detonation created one of unprecedented strength and scope, far more powerful than anyone had predicted. It was like stirring your coffee and accidentally generating a whirlpool strong enough to knock over your neighbor's teacup several blocks away. The pulse traveled the hundreds of miles to Hawaii, inducing massive surges in electrical grids and sensitive electronics, proving, in no uncertain terms, that actions taken high above were not confined to the heavens. They could have tangible, disruptive consequences down on the surface. But the EMP was only one piece of the unexpected aftermath. Up in orbit, circling the Earth, were some of humanity's first tentative steps into space: early satellites. This was the dawn of the space age, a time when these pioneering machines were fragile, experimental craft designed to relay communications or study the Earth's environment. Satellites like Telstar 1, launched just days before Starfish Prime, and Ariel 1, a joint US-UK effort, were minding their own business in the orbital pathways. The Starfish Prime blast and its subsequent effects were incredibly harsh on these delicate machines. The intense radiation and electromagnetic disturbances unleashed by the explosion proved fatal for several satellites. It was like setting off powerful fireworks in your backyard and accidentally taking out your neighbor's newly built treehouse. Our fledgling presence in space, so hard-won, suddenly became much more complicated and hazardous. Perhaps the most lasting, and certainly the most unexpected consequence, was the creation of something entirely new around our planet. Earth naturally possesses radiation belts, immense toroidal regions of high-energy charged particles trapped by the planet's magnetic field, known as the Van Allen belts. They act like invisible shields, but also pose a hazard to spacecraft passing through them. Starfish Prime didn't just add a few particles to these existing belts, it injected a colossal amount of high-energy electrons into the upper atmosphere and the inner Van Allen belt. This artificial injection was so significant that it created a new, distinct, and intense radiation belt. Imagine those natural donuts of particles, and then picture adding a thick, sticky layer of invisible, highly energetic glue to one of them. This new artificial belt was significantly more intense than the natural background radiation, and posed a severe threat to any spacecraft attempting to traverse it. This man-made hazard persisted for several years, effectively contaminating a portion of near-Earth space, a glowing, invisible monument to our experiment high above. We hadn't just thrown a pebble into a pond, we had fundamentally and unintentionally altered a part of Earth's space environment, creating a persistent hazard that simply hadn't existed before. Starfish Prime was in essence a harsh and humbling lesson delivered in a sudden, blinding flash high above the Pacific. It showed us dramatically and undeniably that our actions, particularly with powerful new technologies like nuclear weapons, have complex, far-reaching, and often profoundly unforeseen consequences. The intricate systems of Earth and space are interconnected in ways we were only just beginning to understand. The sheer unexpected magnitude of the EMP effects and the creation of that persistent artificial radiation belt highlighted just how incomplete our knowledge was. The initial measurements of the blast's effects were even difficult to make accurately because the phenomena were so much stronger and more widespread than the instruments were designed to measure. It took later scientific analysis and modeling to truly piece together the full story of what happened and why. What does this nearly forgotten event tell us today? It speaks volumes about the inherent humility required when pushing the boundaries of technology and venturing into new frontiers. It underscores the deep respect we must have for the intricate, often delicate web of reality that connects the Earth and its surrounding space. It teaches us that even when our ambitions reach for the stars, we remain fundamentally connected to the fragile systems that sustain us. So the next time we develop a powerful new technology, the next time we reach for the sky, or even venture into the digital realm with disruptive force, let's remember the lesson of that bright, brief flash in 1962. Let's build with curiosity, yes, with ambition, absolutely, but also with profound caution, with a deep commitment to understanding the potential downstream effects, and with a humble awareness of the delicate balance of everything around us. Because sometimes the most dramatic consequences aren't the ones you plan for, but the ones you never saw coming, echoing silently in the void long after the flash has faded.
Thanks for watching. Like, subscribe, and ring that bell for more history daily.